All right. Hey there, folks. Happy Thursday. We're getting into the back half of our Unit 11, but we are continuing on volume. So today we're talking about the volume of a cone. Before we get into cones, though, we're just going to do a quick little warm-up here to remind you of where we've been. So find the volume of the cylinder, right, this cylinder over here. If the cylinder has a diameter of 6 centimeters and a height of 4 centimeters. All right, take a moment to pause the video now and try this warm-up on your own. All right, and we're back with some answers. So go ahead and check your work. If the diameter is 6 centimeters, then the radius is 3 centimeters. And then we can use our volume formula for the volume of a cylinder or of a prism. Area of the base times height. We know that the area of that circular base is pi r squared. So pop those numbers in there, make some substitutions, simplify it down, and we get 36 pi centimeters cubed because we were talking about volume. All right, let's push forward. So I want you to just think about this. What happens when we compare this cylinder, right, with this cone, given some of the same dimensions, right? So we have a 3 centimeter radius on our cylinder. This cone, we'll say, has a 3 centimeter radius as well. And we have a height of 4 centimeters. Let's say that we also have a height of 4 centimeters on our cone, all right? So in this situation, first think about which of the solids has the greater volume. Which one do you think? All right, once you've picked that answer, what do you think the relationship is between these two solids? Right, so if you want to write something down just for a record, because we'll revisit that thought in a second, you can write something down here. So which one is greater, and what do you think the relationship is between these solids? All right, at this point, we're going to investigate this a little bit further, but I'm going to redirect you to another video that you're going to watch. It's just a few minutes long, and it'll help unlock how we're going to approach cones. So you can get that link 3 ways. You can get it here in this hyperlink. You can get it sort of up here. I'll put a little link in the video, or you can get it down below in the comments, and I will put the link there as well. All right, 3 ways to get that. So go ahead and pause this video, open up that video in a new tab, and then come on back when you're done watching that. All right, welcome back. I am trusting that you have watched that video then, and we're going to push forward in our notes. So question here is, what did you notice about the video? Right, what did you notice about how they were pouring the water and some of the volumes that you saw in the way that those solids were marked off? Right, what did you notice? And then hopefully, as you write down what it is that you noticed, so you can just write that here, did your hypothesis hold true from what you said up here about the relationship between the volumes of those two solids, the cylinder and the cone? Right, I'll give you a moment. You can pause the video and write down anything that you noticed here. All right, the big takeaway that we should be getting out of that video is that the cone filled 1/3 of the cylinder, right? And in addition, and this part's important, the cone and the cylinder had the same radius and height. Right, that bit is important because our understanding of how cones work only operate in relationship to cylinders with the same dimension, right? So if you have a cone and you have a cylinder, but they have different radii or they have different heights, then this whole thing with the 1/3 doesn't work, all right? So they need to have the same radius and height. But that is useful because if we want to find the volume of this cone here, right, well, we already know the volume of the cylinder with the same radius and height. We knew that to be 36 pi centimeters cubed. Right? So if the cone only filled 1/3 of the cylinder, then to find the volume of this cone, we would need 1/3 of the volume of the cylinder, right? So in order to find the volume of the cone, we'll just take that volume of our cylinder and divide it by 3. Right? You can also multiply by 1/3. Again, that's the same thing, right? Dividing by 3 and multiplying, dividing by 3 and multiplying by 1/3 gets you the same thing, all right? And in the end, this will be our answer, 12 pi centimeters cubed for the volume of the cone. All right, so now we can generalize that into a formula that we can use on all of our problems. So the volume of a right cone, and again, when we say right cone, when we use this term, that's referring to the height being perpendicular to the base, right? It's not tilted and slanted. But the volume can be given by this formula. So volume of a cone is equal to, and this is going to be a shortcut. Remember, let's remember that it came from the volume of the cylinder divided by 3. But in this particular case, we can make a substitution for volume of a cylinder, right? That was the area of the base times the height. That's how I find the volume of a cylinder, divided by 3. So I can drop that out, pop that there. Right, this is our formula. And again, you're going to find this on your formula sheet, so make sure that you're using that appropriately, but that's where that's coming from. You can see that we've got our formula for area of a cylinder, and so the cone is 1/3 of that. All right, let's apply it in a problem now. So determine the volume of a cone with a radius of 5 inches. So I'll go ahead and annotate my diagram appropriately. So radius of 5 inches. And a slant height of 13 inches. Now that term is important, slant height, because it's not the height, right? That slant is doing a lot of heavy lifting there in that phrase. So you should not be marking this segment as 13. That would not be accurate, all right? But the slant height is the name that we call this segment sort of on the edge of the cone, right? So if you have a point right here, we call this the vertex of the cone, at the very tip, the sharp part, right? All the way down to a point around the base, right around the circumference of the base. This segment is what we call the slant height, right? So it's kind of like the edge of the cone. So we're saying that that slant height is 13 inches. All right. And because this is a right cone and not an oblique cone, we know that the height of the cone is perpendicular to the base, so we can draw in this right angle. And hopefully now you're seeing that we have a right triangle that is generating this cone. Right? And so in order to find the volume of this cone, we're going to need the area of the base. Well, we can get that because we have the radius. And we're going to need the height. Well, we have a right triangle here. We see that one leg is 5, and the hypotenuse is 13. And you can do Pythagorean theorem, but you should recognize this as a triple. Our missing side of our triangle is going to measure 12 inches. All right, so if we want to go ahead and throw some values into our formula, the volume of the cone is going to be the area of the base. Well, that's pi r squared. We just found our height, which we said was 12, and all of that gets divided by 3. And now we can make some substitutions. So we said our radius was 5. That will get squared. We'll multiply by 12 and then divide by 3. Right? And now I can see that my 12 and my 3 will reduce down to 4. And this 5 squared is 25. So the volume is equal to pi times 25 times 4, which is 100 pi, quick maths. Our unit was inches, and we were talking about volume, inches cubed. All right, so at this point, I feel like you should be comfortable getting the area of a base, and after that, it's just plugging it into a new formula. I think the one thing that I'll tell you to be careful of is just make sure that you know how to operate when we give you slant height or if we ask for slant height. But other than that, you've got 2 practice problems down below, and I will have you enter those answers into Go Formative. And that sort of draws our notes to an end. So thanks for hanging out, doing some maths, and I will see you.